myself Dr. Bharati Patil, working as an assistant professor physics in Maharaja Jivajirao Shinde College, Srigonda, Ahmednagar. We have started our syllabus related to solid state physics, and we have covered few of the points related to chapter number 2, that is X-ray diffraction and other characterization techniques. During our last lecture, we have seen few of the methods of X-ray diffraction. In that, we have covered Lau method of X-ray diffraction, then rotating crystal method of X-ray diffraction, and lastly we have covered the powder diffraction method, which is also known as Diffraction method. So, in today's lecture, we will see few of the applications of these methods of X-ray diffraction. So, first we will start with Lau method. Uses or applications of X-ray diffraction methods. So, in today's lecture, we are going to see the uses or the applications of X-ray diffraction methods. Just now I have told you that we have covered the Lau method, of X-ray diffraction, then rotating crystal method, and we have also covered the powder method. So one by one we will see what are the uses of these X-ray diffraction methods. So first, Lau method. So Lau method is the method of X-ray diffraction in which we are using single crystals for the diffraction of X-rays. It is using single crystals to diffract X-ray. So this is considered as one of the drawback of Lau method, as it is not useful to study the polycrystalline materials. Hence, in Lau method we are using the material which is having single crystalline nature, and its dimensions, there is also restriction on the dimensions of the single crystal used. The dimensions of the single crystals which is used in Lau method should be less than or is equal to 1 mm. So these are the two of the drawbacks related to Lau method. Then the uses of the Lau method are such that with the help of Lau method we are getting the pattern on the photographic film, and that pattern is the symmetric pattern. We are getting symmetric pattern on photographic film. And by using this symmetric pattern, one can understand the orientation of the planes, one can get an idea about, it gives idea about the orientation of the planes also. Due to this symmetric arrangement of the X-ray diffraction pattern, one can get idea about the symmetry of the crystal. So the crystal symmetry which is present in the crystal can also be studied with the help of love pattern, because it is giving us the symmetric pattern on photographic film. And also one can get idea about the orientation of various planes. Then, as we have seen that the symmetric pattern on photographic film, it gives the idea about the orientation of the different planes, and it also gives the idea about the symmetry of the crystal. If the crystal is having fourfold symmetry, then same is reciprocated into its pattern, that is obtained by love method. So with the help of this love method, one can get idea about the shape of the crystal. Also, if we give heat treatment or mechanical treatment to the substance under study or the single crystal under study, then the love pattern that we obtain will have different orientation, and hence whether there is given any heat treatment or the mechanical treatment to the given crystal, that can also be identified with the help of love method, because one can compare the patterns that we have obtained without treatment and with treatment. So, mechanical or thermal treatment effect can be studied. So, these are few of the applications of the love method, but that is, it is used for the identification of the crystal orientations present in single crystal. It cannot be applicable for the polycrystalline materials. Then the restriction is that the single crystal size should be less than 1 mm. Then these are two advantages. Then also one of the advantage of love method is that with the help of love method one cannot identify the crystal structure, because in case of love method we are using the wavelength and it is having polychromatic nature, and hence when we obtain the photographic pattern, then it is seen that the spot which is diffracted is get overlap, and that spot is due to the overlapping of the reflections due to various lambda and n, and hence one cannot identify the crystal structure with the help of love method, but one can identify the orientation of the crystals. Then one can identify the symmetry of the crystal, one can identify the shape of the crystal or unit cell, and one can identify the effect of thermal or mechanical treatment on the crystal. Now we will see the applications of rotating crystal methods. We know that in case of rotating crystal methods, we have used the monochromatic beam of X-ray, and in case of rotating crystal method, we have to rotate the crystal, and hence theta is varying in it and lambda is constant. The applications of rotating crystal method are that with the help of rotating crystal method, one can Find out the crystal structure of simple as well as complex compounds. So, with the help of rotating crystal method, one can identify the crystal structures of simple as well as complex compounds. Also, with the help of rotating crystal methods, one can identify the cell dimensions. That is, one can identify the value of A, value of B, value of C. That is, lattice parameters can be identified with the help of rotating crystal method. Cell dimension can be identified with the help of rotating crystal methods. And finally, as one can identify the dimensions of cell, unit cell, and hence size of unit cell can be identified. So, as we know the value of A, B, C, one can identify the size of unit cell with the help of rotating crystal methods. And what drawback of rotating crystal method is that here also the material or the substance under study should have single crystalline nature. That is the drawback of rotating crystal method. So, the applications of rotating crystal methods are, it is a simple method to identify the crystal structure of simple as well as complex compounds. Then cell dimensions can be identified, that is value of A, B, C, lattice parameters can be identified with the help of it, and one can identify the size of unit cell with the help of rotating crystal methods. And the disadvantage of rotating crystal method is that one cannot use polycrystalline materials for the study of X-rays with the help of rotating crystal methods. The substance should be in single crystal form. Now, last method of X-ray diffraction that we have studied is the powder method. It is the well-known method for the identification of crystals, crystal structure of polycrystalline materials. So, the crystal structure of polycrystalline materials can easily be studied with the help of powder diffraction method. Then, with the help of powder diffraction method, one can identify whether the substance under study is having crystalline nature or amorphous nature. Or amorphous nature of material can be identified. Also, when we give heat treatment or the mechanical strain is produced in the substance, then that can cause the change in the lattice, and that can be identified with the help of powder method. So, it is used to identify the effect of annealing or heat treatment or effect of strain produced on lattice. Then, with the help of powder diffraction method, one can identify the orientation of the various planes. Orientation of various planes can be identified. And by using powder diffraction method, one can identify the size of the unit cell. So, size of the unit cell can be identified with the help of powder diffraction method. That is, with the help of this method, one can identify the value of A, that is lattice parameter, or the value of d, that is interplanar distance. One can identify the glancing angle theta with the help of powder diffraction method. So basically it is used to identify the crystal dimensions with the help of powder diffraction methods, and it is related to polycrystalline materials. So powder, in case of powder method, it is used to study the crystal structure of polycrystalline materials, then crystalline nature, whether the substance is having crystalline nature or amorphous nature, that can be identified with the help of powder diffraction method, because in case of amorphous form there will not be any pattern. Then used to identify the effect of heat treatment or the effect of strain produced on lattice. Then orientation of various planes can be identified with the help of powder method, and size of unit cell can also be identified. In case size of unit cell is nothing but one can identify the value of A or the value of D with the help of powder diffraction method. So in today's lecture we have seen the three types of X-ray diffraction methods, that is Love method, rotating crystal method and powder method, and in brief we have seen what are the uses and what are the few drawbacks of these methods. Thank you.